All right. So, second to last class, but I've decided to release you guys. You've been really good about coming to class, the few of you that are here, and you deserve a break. So I'll be here tomorrow if you have questions, but it's completely optional. There might be fun things going on campus, so you can go to that instead. But if you have questions for me, our exam is on Friday, or on Friday. Everyone, yeah, our exam is on Friday tomorrow. So please be ready. No, that's a joke. On Monday though, close enough. Right. So if you do have questions for me, then I'll be here during our class time, but tomorrow's class, tomorrow is optional. Just bring questions if you have them. So tomorrow is not on Zoom because it gets too complicated. All right, so force you to come in or not because it's optional. All right, so to finish, just to wrap up outliers from Tuesday. We were almost finished. Okay, so here, if we find that our scatter plot has one or more outliers, what do? Right, remembering that the main goal is just to keep as much data as you can, right? And so what you're gonna do is you're gonna fit the line with all the data, right? And then you're gonna remove the outliers, preferably one by one, right? Just incrementally, temporarily, obviously. And then you're gonna fit the line again. And this is where it gets a little bit tricky because this is gonna take some practice, right? So then you compare the slopes and the intercepts, specifically the slope, right? If the slope changes drastically, right? And that's up to you to decide if that was a large change or a small change, or, you know, if you're okay with that, then we usually remove the outliers if they are causing a large change in the slope, right? And so, but that's where it gets a little bit, you have to fly on your own and make those decisions. And there's not really a right or wrong answer. Let's see here. So here, this is from Tuesday. Okay. Just as a reminder, okay. But there was a term called leverage that I want to just introduce, mostly because it's really handy to have. Where did I have it? Here. When you're talking about your outliers, right? So usually if you are working on a project for a client, then you have to explain what you did, right? Somewhere hidden in your methodology section, right? No one reads it, don't worry, but you should feel comfortable explaining why you remove these outliers and things like that. And so one of the terms that you're going to be using is leverage. Okay, so points that fall horizontally away from the center of the cloud, so kind of this way, right? Think of a what's that physics term where it's like a balancing thing? You guys know, I'm making motions. If you're not here, it's hard to know. But anyways, I can't think of the word. Yeah, like this. And then you put something here, and then it goes like this. Whee! It's like leverage. I don't know. Yeah, I don't know. It's not a pulley. It's not a yeah. Anyways, yeah, like a seesaw, totally. So the closer or the further he moves out, so this little guy, as he moves out, right, the more it's going to impact the seesaw, right? And so then, so that's what moving further out horizontally from the center of the cloud, they tend to pull harder on the line, right? And so just to keep an eye out for that. And we call them high leverage. Okay. And I should make this kind of whee. Okay. Just as a final note, just if you thought that you were all done with confidence intervals and hypothesis testing, there's a whole world of inference out there. And so what could we do? We could build a confidence interval around the slope, build a confidence interval around the intercept. You can build what we call prediction intervals, which are slightly different. And so there's lots of other things, but now you have a really solid foundation, at least, of hypothesis testing and inference. So we could, we're not going to, but we could build confidence intervals around the slope, right? Or the intercept if we wanted to. Remember, in the output that I showed you, it gave you the estimate. So it gave you the point estimate for both the slope and the intercept, and it gave you the standard error of the point estimate. So then you can use those as long as you have the critical value, which would be a t for the slope and the intercept. So here, where did I grab that? Oh yeah, jumped around a little bit. So here, using the point estimate and standard error of the point estimate. Dink, dink, from the output. We didn't talk about how to get it. You don't have to. We're kind of beyond that now. Wait. Little E attached. Okay. So you can build a confidence interval, right? And so you have your point estimate for the slope usually is what we talk about. We have B subscript I, right? B0, B1, B2, B3, B4. If you have multiple regression, which we didn't get to, right? But it's just an extension where we add more than one X. I guess I should show you, but I think final exam review is going to be more important today. All right. So, and you need a critical value T star, right? And you'll need the degrees of freedom, but we'll skip that. And then the standard error of the point estimate. Okay. So there are other types of intervals, including prediction intervals. I highlighted too much. Okay. But we're not gonna go there. But what we can do is if you use a regression line right, to predict some value y hat, right, then what we're going to have, right, this is for a single prediction y hat. You can build an interval around y hat because that's also a point estimate, but it behaves a little bit differently just because it's a single prediction. And with that, the end. Now for the final exam information. That was all I wanted to say. Okay, there are a couple of things that are of varying importance. It's a common final exam. There's that 230 sections. And so I know you're used to themed exams. And what I've decided to do, so it's not themed originally, I'll just change all the characters to be the animal that I want. It's not gonna make sense, but it does make it kind of funny. So it'll be themed, but not in the way you think. But yeah, so anyways, that's a heads up. You don't have to give the type of question. Obviously, it's good if you kind of figure out what type of question it is, because that's going to tell you how to solve the problem, right? And so here, just a couple of notes. So you're not giving the type for marks, at least, but obviously it's good. That's why I make you do it, because it's so important that you identify what type of question it is, and then that really kind of zeroes you in on what to do. For your assumptions, it's easier because you're just going to have checkboxes and you select all that apply and you don't have to do anything for it. Okay, so that's kind of a load off. I was like, hey, but my guys, they know how to do it. They know how to check all the assumptions properly. But so here the assumptions are going to be our checkboxes, our check all that apply. Obviously, I subtract marks if you pick one that's wrong, right? So there's kind of a scheme. Okay. So you won't need to check. No need to actually check the assumptions. Feels like kind of a break for the final exam, right? Because the assumptions takes up a lot of time, right? But you still need. Yeah, so you still need to remember what assumptions you would need to check. Okay. But then it's just a series of check boxes.
And then for those questions, they'll be given, like, we'll have more than 30 or...
Well, that'll be in the question, right? So so the options might be, so let's talk about a one sample mean. The options might be the sample is randomly selected, check. The sample size is more than 30, so we can assume normality. Maybe that's not true, right? Maybe you have a sample size that's less than 30, so you wouldn't check that one. So then you would say, pick the next option, which might be the sample size 30, so we have to check that there are no outliers, right?
But then we will have to go in to actually check that there's no outliers.
No. So you don't actually have to do it. You just have to tell me what you should be doing.
Yeah.
So, yeah, so you don't actually have to check them. You just, gets confusing because it's check all that apply, but you don't have to do anything for the assumptions. You just have to tell me what you should be doing. And then you can assume that all the assumptions are met.
What can
I don't know, E something?
Third classroom, second floor,
Yeah,
E208.
But it's like a single.
yeah, right.
Because I know my comp class, like my comp class was 30 people, but I tested in the room 60.
Oh, well, some of Jen's class might come over because she has a large class. So we might be they might overflow into our class, but we fit in one room. Yeah. So, yeah, I don't know.
Pretty late.
Yes. Okay. So the assumptions, that's good news. The bad news is for the 5-number summary question, there's 21 points. Okay. So the hardest part is sorting them all. Just be careful. Okay. If you show me the values sorted, okay, and you just through with that, right? So obviously you have to sort the data, right? But if for some reason you mixed something up and you did it wrong, as long as you follow through with those values, that's fine. Just show me what you did. Okay, I know 21 is well, it's crazy. But now you know. Okay, so because I think I've promised that I wouldn't do more than 13 or so, but here I am. Should have looked at the final exam. Well, so yeah, so it has to be common, but anyways, so the 5-number summary has 21 data points. So be careful sorting. Yeah. So what kind of questions should you be expecting? I posted it on Moodle. Let's see here. Oh, that's not my internet. Hey, what? Business math, you guys wish. Wouldn't that be so fun? Mortgages and things. All right. I'm gonna make it so that I look like a student. Okay. So down at the very bottom, look at all the stuff we did. Crazy. Oh yeah, E208. I don't know which room that is. I think it's probably one of the first ones, right? Those, I don't know. I've never thought about it, to be honest. All right, so let's see here. Gonna blow it up a little bit. Oh, you know what? This is all dead space over here. I don't need that. Okay, so there are 10 long answer questions. No short answers, just long answer questions. Okay, and they're not necessarily in this order because I get kind of vague here in the middle. Okay, that's to keep you on your toes. But question 1 is from chapter 1, numerical analysis. That's where you're gonna have to do the 5-number summary, check for outliers, right? Look at a histogram. What would the box plot look like, right? And so here. All right, so here, this is the 5-number summary. which I already told you about. From a histogram, describe the distribution. Are there any outliers? That's when you have to use the 1.5 IQR rule, right? And what would a box plot look like? I'll just say box plots. Second one is a tree diagram. And I'm sure I've had it at some point, but it's going to have 3 branches at the top. Okay. And so it's going to look like this. Okay, so 3 branches, and then followed by another 3 branches. So that's what it's going to look like. Okay. I'll say 3 branches, 2 levels. And then use those to find probabilities, right? Using those probability rules. Okay. And from the formula sheet, right? You're looking here. You'll know that it's a tree diagram one with probabilities because it'll ask you for a tree diagram. Draw a tree diagram. Tree diagram. Okay. So one's not easy, but easy enough to spot. Okay. Oh, and we did that on quiz 1. So everything, all the practice for, we did it, or was it quiz 2? Probability. This is from quiz number 1. Okay, wow, that's so nice of me. Usually I squeeze it on quiz 1, making quiz 1 a lot harder. Yeah, nice. Okay, so that's from quiz 2. So that's kind of where to go for practice. Okay, and I posted practice for quiz 2. You've done the assignments leading up to each of these quizzes, right? So you've got a lot going on. Normal distribution to find probabilities. That's when you had your z-scores, right? And you're using the area under the curve, right? Centered on the mean. In terms of the formula sheet, let's see if I can write on this. You're using these formulas. Okay. And the t-table, of course, to find those probabilities. Okay. What quiz was this on? Is this on quiz 3? Or 2? I feel like it might have been 2. You guys are on it.
3 and 4 were really similar.
Yeah, I feel like, okay, yeah. Thank you. The other ones I'll have under control. It's just these first few that I'm like, I don't know when I did it. All right. So then you have the binomial probabilities, right, with the normal approximation. Now I seem to remember I didn't put the normal approximation on the quiz, but I posted a bonus assignment, I feel like, or an extra assignment. Might not have been on the quiz. So, but this is also quiz 2 then. Crammed a lot onto quiz 2. In my mind, it's all the boring stuff. Just got it over with in quiz 2 and then moved on to fun things for quiz 3 and 4. I'll say on the quiz, maybe? Can't remember. I don't have a copy with me. Right now, I can't even remember what the animal was. Oh, marmots. Is it marmots or meerkats? Oh, I have a marmot test too, but okay. No, I don't think so. I think we ran out of time and then covered it after the quiz, is what I suspect. But there is a practice final posted and it's in there. So here, what part of the formula sheet might be helpful? Well, it's the binomial section. You can find individual probabilities, right, of K successes in N trials, right? And then you can use the mean and the standard deviation for the normal approximation, assuming that you have at least 10 successes and 10 failures, right? That's the first time that we saw that condition. And so here you have to check the conditions. Check the conditions before using the normal approximation. Okay. I skipped to the goodness of fit test and the Anova because I've lumped, there's a confidence interval and a confidence interval and a hypothesis test. So this is where the order is going to change here. But let's talk about the goodness of fit test. This is a chi-squared goodness of fit test, which was on quiz number 3, but I think we did a test of independence on quiz 3, which is a 2-way table. A goodness of fit test is just a 1-way table, so one categorical variable with so one categorical variable with 3 plus categories. Okay. Someone knocking at the door? Are you guys hearing that? Come in.
Do you know which process this is?
She wasn't here for us. Wrong number, so to speak. Okay. So the goodness of fit test, which means on your formula sheet, it's this one, whereas on, I think, quiz 3, I feel like I got you to do this one. Oh, is that the one you got to pick? How nice of me. Now you don't get to pick. School of Hard Knocks here. All right. So chi-squared goodness of fit test. I want to brush up on that. It's been a while, right? But you don't have to do the test of independence, which is, in my opinion, way harder. Okay. Then we have the Anova. The Anova is when, so we only used it for one numerical variable, right, across 3 or more groups. Right? So one numerical variable across 3 or plus groups. All right, so you're comparing the means across more than 2 groups, and the Anova, it was on quiz number 4. And from the formula sheet, it was this one. Dink. All right. Seven, 8, 9. Haha. Like that joke. Why was 9 scared? Oh, why? Yeah, why was? Because 7, 8, 9. Thank you. These are from quiz number 3 and number 4. Total wild cards. Okay. So the confidence intervals, let's start there. We made confidence intervals for one sample proportion. If that's the case, then you also have to do a sample size calculation because that's the only time that we do it. I'll say and sample size calculation. Wink, wink. Okay. What else did we do? We did one for 2 sample proportions. These were on, you studied them for quiz number 3. They weren't all on there. One sample mean. Paired data. Or 2 independent samples. Or sample means. Those are all from quiz number 4. Okay. So those are the options. So it's 2 of those. Okay. That's not very helpful, is it? I know it's not. Okay. But that's where I want to make the decision tree to help you decide which type. So for the hypothesis test, again, it's the same categories. Sure, I can write it all in orange. But this is all the same. In fact, it's all the same. But there's no sample size calculation if it's a hypothesis test. So this is from quiz number 3, and this is from quiz number 4. Lots of options, I know that. But three of the questions are from here. Okay. And if you had to guess which one of these is definitely an option, maybe it would be something here or something like that. Something. But I didn't say anything. All right. The other 2 will be wild cards. How about that? All right. The last question. Is going to be worth quite a bit. Okay. I think it's 14 or 15 marks out of 95. Okay. Because you haven't been tested on it yet, but also it's super fun and it should be easy marks. Okay. And so that's why I like to do it that way. And hopefully that doesn't backfire. No, it never does. It never does. Okay. So here, this one is not tested yet. Right. But it'll be kind of around 15 marks. Can't spell at all. Out of 95. Okay, so it's quite important. Okay. But it's also very prescribed. Okay. You have to be able to, let's list all the things, right? Describe the relationship. So given a scatter plot, describe the relationship. That means talking about the shape, the direction, and the strength, right? Touching on all 3 of those things. You have to be able to find the slope and interpret the slope for each unit increase in X. We expect to see a slope increase in the predicted value of Y. Find the intercept and interpret the intercept. The intercept is the predicted value of Y when X is 0, right? And so, yes, there's some minor calculations that you need to do, but the hard part is figuring out which is your X and which is your Y, which I guess should be part of this, but goes without saying. right? And then given the information, right, map it to the right spot. Okay. Construct the least squares regression line. That's just writing out y hat equals b naught plus b1x with the values for the intercept and the slope inserted. Okay. For some reason, that one throws people off, but then they end up writing it somewhere else because they think, oh, that's way too easy. Why would that be a mark? Well, it is. Okay. Then you use the line to predict a value. Then predict a value, but you're extrapolating usually, right? And so here I'll just say extrapolation. It's when you use a value of x beyond the range of the data, right? And then, so it might be your best guess, but it's also an unreliable prediction because you're extrapolating. Okay? And then R squared. R squared is the percentage of variability in y explained by the least squares regression line on x, right? That requires you to have the correlation. The flip side would be if the R squared was given to you in the beginning, right? 74% of the variability in y is explained by the least squares regression line on x. What's the correlation? Then you have to find the correlation, right? A little bit more work, but that's kind of the two ways that these questions can go. Okay? So quite a few marks here, right? Does it add up to 15? I don't know. I'll make it work. These are 2, 1, 2, 3, 4. Usually it's more than 1 mark each. Okay. Good. And that's it. Okay. Let me go back to our Moodle page. So I did post, this is my practice for the final. Confession time, there's a heavy focus on those, the inference questions, those 3, the confidence intervals and the hypothesis testing on here, because that's what I want you to focus on, right? The other ones are just kind of, you can find practice problems because you know what to look for, right? These ones, first step, what I would say is just read through all of them and figure out what type of question it is, right? Can you answer this question? Just knowing the type of question is really helpful. So I think I have quite a few here. Yes, quite a few indeed. And there's a regression question. I think there's 2 regression questions, just to give you an idea of how they can go. Okay, because it's new, so I do have those on there. One thing about the solutions is that the solutions are programmed in R, so sometimes it'll keep more decimal places in the background than it's showing. And I know that's kind of a problem that I haven't tackled for the regression especially. Okay. But if your answer is close, right, with the rounded values, then it's okay. Okay? So just be a little bit lenient with the solutions, right? Because sometimes it knows more than it's showing you, but you can only work with what you've got. Okay, so the solutions are there. And then there's this practice final that Jen put together. And just to give you an idea of kind of the format, okay, it's a little bit different, but just for some practice. This is actually the reason why I tend to not give practice finals, Because if you're studying this and you're so prepared to really nail this final exam, then the one that I give you is going to feel very different, right? This is just to get a feel for things, okay? For example, I'm not going to make you calculate the standard deviation, right? That's a no-go for me. Let me bring this into, sure, I'll add it to the note. I'm not scared. And then the solutions, so these are Jen's solutions. I mean, it might be good to kind of brush up, but you'll see she does things a little bit different than how we did it. She doesn't use the patent pending boop, boop, boop method, for example, right? She actually does the calculation to find the location of the median, but then you still have to find it. It's crazy. Why not just go straight to the source? So grain of salt with these, if you arrive at the same answer, you're good. Okay, but so here, I just want to go through and make some notes, not on the final, just to have an idea of kind of what you should be able to do and what you don't have to do. Okay, but here's some practice. Find the mean, find the median, and the 5-number summary. Are there any outliers using the 1.5 IQR rule? Okay. Tree diagram. Let's see how many branches there are. I hate reading these. Okay, you're playing 2 games in a row, which means you have 2 layers in your tree diagram. The first game is the semifinals. If you win the semifinals, you go on to the gold finals. If you win the gold finals, you get a gold medal. If you lose the gold, oh man, so bored, / confused. If you lose the gold finals, you get a silver medal. If you lose the semifinals, you go on to the bronze finals. If you win the bronze finals, you get a bronze medal. If you lose the bronze finals, you don't get any medal. I mean, this is all true and we can all get on board with this, but man, oh man, how do we draw it, right? And so first branch is gonna be the semifinals, right? You either win or you lose. I guess they have WSLS. Okay. And then you can either win or lose, but notice how this is only 2 and 2. And I said we'd have 3 and 3. Okay. And so just kind of maybe try to find a practice problem that has 3 branches at the top. And if I haven't posted any, I'll make one. Okay. But this is good for practice, especially reading these very confusing sentences and kind of sorting out the information, right? It'll all fall out, but yeah, so then you have to build a tree diagram, labeling all the appropriate probabilities, and then what is the probability that you win your second game, you get a silver, given that you won the semifinals, all that kind of fun stuff. Oh, it's all coming back to us. Okay. Statisticians at Wilmot, very aware of branding and things, so not Walmart, Wilmot, have determined that time spent has a mean of 9.8 and a standard deviation of 3.7. We assume the distribution is normal, so this is a Z-score type of question, right? One thing that I will say is we didn't do this because it assumes that we know sigma and we never will. So that's not on the final. I replaced it with just another one of these types of questions. Okay. I think the solutions use the actual Z table whereas we were just using the ranges, right? But if your range captures the actual value that's given, then you're probably right. And if you want me to check it, I will. Now that I think about it, the solutions in my practice for the final will also have the Z score or the Z table. So I should fix that. But also feels unlikely. But if you're unsure about your ranges, then you can check with me. Here, we're given some probability of a success and 10 trials. This is a binomial question, and this is where we're asked to use the normal approximation. Okay, will prompt you to make sure to test the conditions, right? And so it'll ask you to use the normal approximation. Okay, so you don't have to figure out when to use it. Okay, then we're on to a confidence interval. Sample size calculations, both ways, right? There are two ways to do it. Hypothesis test. And these are just examples, right? So I wouldn't put too much stock in these ones in particular, right? But here, this is also a hypothesis test. Here's a goodness of fit test for practice. Hypothesis test, hey, that's more. And a confidence interval, Anova. I'm gonna give you the totals, right? And so I'm gonna give you 2 out of the 3. Of the sums of squares, okay? In the solutions, they actually calculate the sums of squares between and within. The within is the residuals, okay? But I changed it to match how we were doing it, right? Because I really see no point in using these values to calculate the sums of squares by hand. You should just be able to look at some output and make sure it makes sense. So it'll be like what we did, okay? But the solutions are different. This one actually wasn't supposed to be on here. We didn't do this. Let me see here. Okay. Here's a regression question. Okay. You have to find the mean, you have to find, or the means, but you're given Sx, Sy, and the covariance Sxy, which means you'd have to calculate R, but you have all the things that you need, so you can do that. Yeah, find the correlation, find the least squares regression line. You do not have to make a scatter plot. That's crazy. I do cut those, that's crazy. But you do have to do, so I would probably have a look at those practice for the final ones that I posted instead. And then predict. See practice for the final. For better examples, right? Or more appropriate to what I'm going to ask you. Okay. All right. I do want to make our decision tree, but I'm gonna have to do it on the board, I think. But I brought you guys huge paper. You don't have to use it now. You can do like a rough draft, but I think it might be nice to have, especially for studying. Then you can put it, well, this is one of those times when if you slept in a bunk bed, it'd be really handy because then you can just put it here and just look at it as you're falling asleep. Oh yeah. Put you to sleep. Okay, so what I'm gonna do is I'm going to stop the recording, but I'll post it as part of I'll post it on Moodle, the tree that we make, but I'm gonna have to make it on the board. So I'm gonna have to let you guys go. Let's see here. So tomorrow is optional. Oh, and I guess I should thank you for a great term. We are not done yet, but I guess we are. All right, I'll stop this recording here.